Hey there, people. This is Jay, and I am starting a new video series on performing various statistical tests using SPSS. In this video, specifically, I'll be talking about how to perform the independent sample t-test and how to check for the assumptions that are related with the test. So, as we know, we perform the independent sample t-test to check if the mean values between two groups differs statistically. Coming back to the assumptions, first one is normality distribution. Both the groups should be normally distributed. The homogeneity of variance between two groups should be equal. If we have unequal or unbalanced number of observation in the study, or the study design is unbalanced, that is group 1 observation differs from number of observation from group 2, we can still perform the independent sample t-test, but normality should still be satisfied, as well as the homogeneity of variance should be equal. But if we have equal number of observations in both the groups, but homogeneity of variance is not equal, then still we can perform the independent sample t-test. So let's see how we can do that in SPSS. Here I have two sets of data. One group is control and the second one is treatment, and the corresponding dependent variable. So first let's check for normality distribution. So we go to analyze, descriptive statistics, and then explore. We move our dependent variable into the dependent list and the group into the factor list. We go to statistics. Make sure that you have checked the descriptive checkbox. We'll keep the default value of confidence interval for me at 95%. We go to plots. We uncheck stem and leaf, but we check the histogram. We'll check normality plots with test. We continue and click OK. So results are given in summary descriptives. The actual Shapiro-Wilk and Kolmogorov-Smirnov test. We also have histogram as well as QP plots. So let's go through them one by one. So we have two groups, that is control and treatment. Number of observation in control group is 20, while number of observations in treatment group is 21. There are no missing observations in either of the groups. Moving on to the descriptives, uh, which has mean for both the groups, that is 24 for control and 39 for treatment. We also get the median variance, standard deviation, and so on. But for uh, checking normal distribution, we'll only focus on two values, that is skewness and kurtosis. So in general, skewness between -2 and +2 is accepted uh, for the normally distributed data. Same goes for kurtosis value. Kurtosis between -2 and +2 is enough to say that the data is normally distributed. So as we can see, skewness and kurtosis for control group as well as skewness and kurtosis for treatment group is in the range of -2 and +2. So we have one evidence that our data is normally distributed. Let's look at the histogram. Even the histogram looks quite bell shaped. However, the treatment histogram looks slightly skewed. Looking at the QQ plots, uh, the data is quite normally distributed. The significance for Shapiro-Wilk test is more than 0.05. That means we do not have enough confidence to say that our data is not normally distributed. So we have checked our first assumption of normal distribution. Now let's move on to the homogeneity of variance. In SPSS, both homogeneity of variance and the independent sample t-test itself is analyzed at once. So we go to again analyze, compare means, and into dependent sample t-test. We move our dependent variable into the test variable box and our group into the grouping variable. We'll define the groups and we'll directly click OK. So again, the output is divided into three primary categories: the group statistics, independent sample test, and the effect size. For the effect size, we'll talk about in other video. Uh, we'll primarily focus on the independent sample t-test box. Again, control and treatment groups has different observations. The mean value is given as well as standard deviation and standard error of mean. SPSS performs Levin's test to check homogeneity of variance uh, when performing independent sample t-test. So looking at the significance value of Levin's test, we can see that data has homogeneity of variance assumption satisfied. We also get the t statistics as well as degree of freedom, and two-tailed significant value of independent sample t-test is less than 0.05. That means uh, there is a statistical difference in the mean value of control and treatment. So for example, if the homogeneity of assumption was violated, then instead of looking at the significant value corresponding to equivariance assumption, we would look at the equivariance not assumed value. That would give us more robust result and with corrected type 1 error.